Welcome everybody. This is Tim. I'm putting out a video for my family and friends, talking a little bit about how to improve your Wi-Fi coverage in your house and your internet experience. We all know that everybody is working from home these days, schooling from home, and watching Netflix and all that comes over the internet. So I thought I'd put this video together to help some of you out. It's going to cover some of the fundamentals of networking just so you have an idea of what the pieces are, and then some recommendations for different products. Today we're going to be covering, first of all, your network. What is it really? What makes it up? And it's a little bit techy, but you don't really have to memorize much on it. You just have to have kind of a theoretical understanding of it. We're going to talk about some basic recommendations, what type of things you can do to improve your network without buying a single thing. In addition to that, we're going to talk about speeds. A lot of people buying products and trying to improve their speed by improving their wireless selection. Well, unless you improve your internet selection and your router's port speeds, it may not be effective, and we'll talk about what those are. We're going to look at three products: network extenders, Powerline, and mesh, the three main types of products, and I'll give you a recommendation I have for each. This is being recorded early May 2020, and I'm going to go over recommendations, a couple that I pulled off of PC Magazine and a couple other sites, and those are some of the recommendations I'm going to make. And then we're going to talk about one other thing. Depending on what you select and what products you may or may not go with, you may have an issue with addressing. And I'll talk about a little bit about how addressing works without getting too heavy in it, and just tell you what you need to consider when that comes about. So let's get started and just talk about what a network is. A network basically is going to provide us access to the internet. It's going to need a device that knows how to route packets in and out of your house. It's connected to the internet, and that's the wire that typically goes outside your house. In addition, we'll have a firewall. The firewall is there to protect us, and the implicit rules are: don't allow anything inbound to my house that I didn't ask for, block it all, and then anything I ask for from inside my house, allow it out to get what it wants and come back in. We have a switch, and all a switch is much like an extension cord. When I want more outlets, I want to plug some stuff in. Typically, the firewall is going to be plugged into it. The computer can be plugged into it. And then when we didn't have wireless, this is what a network looked like, but when wireless came about, we would take an access point and connect it via a wire. It actually has a wire connection in there. And then the wireless devices, laptops, tablets, phones, could connect to the wireless access point and be mobile and all that, and the access point would get them on the network through the switch. The nice thing is this has all been simplified in your house, and it's all been pretty much rolled up into one device. Everything's been rolled up into a typical, what we call broadband router. You'll hear it called a Wi-Fi router. You'll hear it called my router. It's really all four things wrapped up into one. And the wired connections of computers go into the ports in the back. They're usually grouped together, four of them. Maybe six of them, maybe three of them. Then the one off by itself is the one that goes to the internet. And the laptop connects to the wireless antenna and is the equivalent in most cases of a wired connection to the computer before it. They're basically treated the same way. Let's go on to the basics and some basic recommendations of what you can do to improve your network today without buying a single thing. First, understand that your wireless emits from the central device. It has typically one or two radios, either a 2.4 gigahertz radio or a 5 gigahertz radio. Now the radio types, the 5 gigahertz gives a lot more bandwidth, but has poorer coverage through materials. And the 2.4 has better coverage through materials, but slower bandwidth. And I don't want you to think 2.4 is bad, because the bandwidth you're getting is probably far more than you actually need. Understand that SSID is the name of our network. In my case, I called it Tim's Wi-Fi. And you would have a password, hopefully. If you're going to do a password, I always recommend a WPA2 password. Don't use WEP, which are keys, and don't use WPA1. Just go with WPA2, and that's pretty much an easy-to-use password. When you have this device in your house, they usually jam it somewhere, somebody throws it on the floor or something. That's all bad. The key to this is those antennas, in order to put out a good signal, need to be at least 14 inches away from anything, including the wall. So if we can move this out a foot from the wall, from devices, don't hide it behind stuff. Don't stick it on the floor alongside your computer cabinet if you have that on the floor or even on the floor. So let's go ahead and make sure that it sits on a desktop in the open, it's not behind anything. The second thing you can do, and it might not be easy enough because you might not have wires or options to do it, but is to get the unit placed somewhere in the center of the house. The center in the house means directionally, to get anywhere, it has to go through less floor or less ceiling. To get there, less walls. So centrally locating it may cover your house in its entirety. If you have a bigger house, it's probably not. If you have a more vertical house, townhouse, probably not. Going through floors and stuff like that is tough. So we're going to show you some of those options and those other products later on in these slides. There's some basics to improve the coverage. Let's talk a little bit about speeds. Before you go and buy something, you got to know what you're improving. So you have a couple different components. You got the actual physical wire from your router into the internet provider. That wire has limitations of how fast it can go. You have to be aware of what that is. We're going to talk about it in a second. You have computers that are wired in. Those wires have limitations. And then you have laptops and phones that connect to the wireless. And depending on the architecture that you bought, the wireless will have limitations. Now, I'm not going to read through all these, but here are some of the standards and when approximately they came out. And they're not, for any networking people, they know reading this is not all of the standards, not 100% accurate. It's a guideline. Back in 97, we had a 2 megabit 802.11 network. It ran on a 2.4 gigahertz radio, blah, blah, blah. If you buy anything today, you're going to be getting anywhere from probably the top two items, an AC or an AD. And that's great. 3 gigahertz, wow, that's going to go really fast. Well, not really. The point is, my internet's not even close to being that fast. And that's why I tell people wireless is more important to have good coverage and a good, strong connection than to have the fastest you can possibly have. If I was sending a lot of data between the laptop and the computer, then the wireless would make sense to get it as fast as possible. But most of the use here is to the internet. So no matter how fast my Wi-Fi is, if my internet is slow, I can have a 3 gig Wi-Fi speed, but if I got a 50 meg internet, 6 gig is 6,000 meg. A 50 meg internet connection will not be able to carry that. So I pay all this money for a 6 gig Wi-Fi and I can't actually use it for anything. So that's why I lay this out. Most stuff that you buy today will be probably AD, probably AC, and you're going to have plenty of bandwidth as long as it coverage and you get enough bars. So let's talk about those port speeds and the wires themselves. Wires themselves have limits on how much they can carry. Mainly the wire based on its type and the device, this router, and whatever the carrier puts in. Most people are going to never see 10 megabit port speeds. They're pretty much gone. But most people in their house will have either 100 or 1,000, which is a gig, capability there. And the reason I pointed it out here is because if you go to, let's say, Fios or Comcast, and you say, I want to up my bandwidth from 75 meg or 50 meg or whatever you have to 150, and this router is limited to 100, that means they're going to tell you you are going to be required to swap the router out because it doesn't have the capability of going that high. You're going to need one with gig capability. If you get one with gig capability and you're, let's say you're already running 150 and you tell them you want to bump it to 300 and they tell you you need a new router, they're lying. That router can carry a gig and can carry 300 meg. So keep that in mind. Port speeds are capabilities of the wires and the ports themselves, but they're not the subscription that you buy. Port speeds can also impact the wired devices on the inside, and typically if the router has port speed limitations of a gig or 1,000 meg, it's going to have that both on the inside and the outside. The subscriptions are what you buy from the carrier. You usually buy a different upload and a download. So let's say, for example, I sign up with Fios and I get a 100 meg download and a 20 meg upload. Well, why do they do that? Why do they load it that way? It's because when you use the internet, typically you're sending up a request. Let's say you're going to YouTube. Well, my request is only so many characters there. That's actually bytes. It's not even kilobytes, megabytes, or gigabytes. It's the tiniest little bit of text. But what comes back in return to my request is a stream of data that I'm going to watch. So huge amounts of data coming into your house, little tiny amounts of data going out of your house. And that's what you have to consider when you buy those subscriptions. Now, if I wanted to bump this bandwidth up from 100 meg to 200 meg, as long as my port speeds are a gig, I'm fine. If my port speeds are 100 meg, I am going to have to swap the broadband router out for an upgraded one. So on to the first product. First one we review is called an extender. It has one sole goal of taking the network that you have and extending it further. So in this environment, I have an internet connection, my router with its SSID, and my laptop off to the right. Maybe it's out a little too far, not getting right coverage. The router itself will have a certain range of coverage. And what we do is we take an extender, and this one here, you kind of plug into the wall. You configure it to connect back to the broadband. Now, because it's repeating a signal, we do not want to put it at the edge of coverage. We want to put it about 75% out from the wireless router that we have. You might say, well, how can I do that? Well, just use your phone and look at the bars, connect to your Wi-Fi, walk away from it until you are somewhere a little bit less or in the middle, and that's where you want to put it. You don't really want to go out as far as having just one bar. You're going to be repeating garbage, but you don't have to put it super close either, so just keep that in mind. You put that device in, it connects back to your router, and then it is going to generate a radio signal. Now, that's written in red because I don't like the extenders that change the name of your network, meaning if I put a cheaper extender in, instead of it repeating Tim's Wi-Fi, it makes up its own name. Tim's Wi-Fi underscore 2.4 underscore 5 is a common way of doing it. Well, that's annoying. Now that laptop has to know when to connect to one and when to connect to the other. What I recommend is the ones that repeat the same name of the network. So you don't really have to know where you are or whether your laptop is connecting to the extender or the broadband router. So once that matches and it repeats that signal out, then we get a nice coverage area that extends even further away and covers our dead zones or our low-lying areas. And the laptop can connect and everybody's happy. I recommend, we just did this for another person, it worked out pretty good, very easy to set up, was the N300. It's been around a little bit. It gets okay reviews, but it's also only $54 to repeat it. And if you have one spot that's dead, let's say that it's one end of your house or one place, they tend to work pretty well for covering those singular spots for dead spots. So let's go on to the next type, which is Powerline. This one you're probably not going to use unless you have a very specific reason. What this does is you have your regular broadband router giving its SSID, coverage area. You have your electrical system in your house. And what this does is we install one device we actually plug it in the wall. That's how it gets connected to the electrical system. And then it gets wired into your router. So you plug it in somewhere near your router. And then you plug the other end, whether it's a wired or wireless end. They have both. This one is a wireless that you see with two antennas. Some of them are wired, means they have like 4 ports on them. And they basically give you 4 ports of network. So if you wanted to do that somewhere near, let's say, an Xbox that you want to plug in, you can do it. And then these establish a connection over the actual power lines in your house. So you're not running any wires. And basically it puts the signal out and lights up the SSID out farther. Your laptop connects onto that, which bridges us through the electrical system and back to the router. Powerline is a very unique type of implementation. You've got to be aware or, trust that your electrical system is fairly good and not have too complex of an electrical system. If you're in a building, like an apartment building or something like that, might not be the selection. But if you're in a single family home, I've done this, it's worked great. I ran Ethernet out to my Christmas lights to control them. Fabulous system. Again, very specific use, but that's a Powerline system. I recommend a couple different products for this. The one that PC Magazine's recommending now is this AV2000, which is also by TP-Link. So the mesh, this is the latest and greatest. This is what I'm going to recommend for most people, and this is what I'm putting in my house. I already have a mesh, but it's a bit older, so I'm going to be replacing mine. Now, the way a mesh works is you basically want to turn off the antennas, the wireless part of that router, if you remember, it was 4 pieces, a router, a firewall, switch, and a wireless. We turn the wireless off there because we don't need it. Then what we do is we buy these nodes and we plug one in and basically create the wireless network there. That emits the wireless coverage. Then we plug in additional nodes. For a 3,000 square foot house, maybe you're going to do 2 nodes additional to the first one, so a total of 3. In a smaller house, you can do 2. They sell them in packs like bundles. So I'm buying myself the 3-pack because I want to put one downstairs somewhere that it can bleed out to where our pool is so people can be on their Wi-Fi out there, and then one up on the far end of the house to get to the upper floors. So the mesh nodes sit in like that. They connect back to mesh node 1 via wireless, so there's no wires to run, and then they emit the same SSID to cover everything, and your nodes or your computers connect to one of them, whichever one happens to be closest at the time. Mesh networks are very, very easy to use. Basically an evolution of what network extenders started doing, but they kind of work like a mesh. They have multi-frequency backhauls. In the case of the one I'm recommending, they have really nice backhauls. The backhaul is the connection from one mesh to the other, this piece. So you want this to be fairly strong and carry bandwidth through it fairly well. So product I'm recommending has been recommended for quite a bit over the last year and a half. It is the Deco M9. I know it says ACC 2200 Smart Home Mesh. The actual product is the M9, the Deco M9. That's this guy. I think the AC 2200 is the bundle of 3 or a bundle of 2. They basically sell them in different size packs, and then you can add on additional ones. So we have a couple little complications depending on what you buy. Now, the products I recommended won't have this problem. If you decide to buy anything else, you've got to watch out for things that your new device will do that will conflict with your broadband router and what it's doing. And the main thing that conflicts is the service called DHCP. DHCP is the addressing system. Let me show you how it works. Basically, when a computer connects to your network, it doesn't have any information on how to use your network. It actually broadcasts out, hey, anyone out there, I want an address to use this network. Can I have one, please? And it's not authenticated. It's not controlled. Any device can respond to it. And typically the device that responds is your router because it is a DHCP server or a dynamic addressing server. It says, here you go, and it gives it an address. It also gives it all the information it needs to know to how to connect to the internet or what we call any other network, to route off network. So it's going to say, here's your address, and here, talk to me next time you need to get to the internet or anywhere else. And that's how DHCP works. Now, if you introduce a third device, another device that is also a DHCP server because you want to maybe disable the wireless here in this broadband router, and you're going to put a stronger one on, you have to remember those routers are not the extenders and stuff I'm recommending, but these routers are capable and probably by default enabled as DHCP servers themselves. So what happens is the laptop connects, he says, can I have an address? And both respond. Now, if the laptop gets the one from the broadband router in the black dialog box there, everything will work fine. But if it gets the answer from the DHCP router with the 4 antennas, it won't actually work because that DHCP server doesn't actually have the direct connection to the internet, and that's where it poses a problem. So if you're going to add a device, always check the documentation to whether it has a router in it that is giving out dynamic addresses called DHCP. And if it does, in order to stop your laptop from having problems, go ahead and turn that feature off. It's usually just a checkbox that says don't give out addresses, and then you'll be fine. You can actually have the laptop connect to this router down here and then get on the internet because the wireless for this router is stronger. But you don't want it doing all the other features. You don't want it doing the routing. You don't want it doing the firewall. And you don't want it doing the DHCP and that sort of stuff. Just the wireless access point. So that was the only thing you might run into. In summary, we talked about the network extender, which is okay for selective coverage holes to patch dead zones. It's cheap. They typically run, I'm going to say about $60. $40 to $60. If you get the 40 ones, you're probably going to get the bad ones that rename the network. And they're easy to set up. Typically, they come with fairly simple instructions to set them up. The Powerline, you're going to use this when other options don't work for your Wi-Fi, or you want to put physical ports somewhere. I had a client of mine whose son had a Xbox, and he didn't want it on wireless because the wireless doesn't perform the same as a wired connection. So we did the Powerline, and we plugged that thing in right next to his Xbox and wired into that and worked great. And then the mesh. The mesh is what I'm recommending. It typically gives the best coverage. They're the newest technologies for giving you the best bandwidth through your network, and they're easy to set up, and that is my recommendation. I will close this video out with the last part of my recommendation, which is how much bandwidth you need on the internet side of that router. What I'm going to do is I'm going to end this slideshow. I'm going to jump back to our original network here, which is this guy. And let me just pull that up. I thought about adding this afterwards. So, the wireless technology you buy is this dotted line. It only gets you to the router. This red line over here, the red line over here is the internet service you buy. Now, you need to know, if I have really good wireless coverage and really good wireless, but I got a 50 meg download and a 10 meg upload, you're not going to be doing much on that other than surfing the web a bit. You're not going to be watching Netflix. An example is we do bandwidth analysis. A Netflix stream might take anywhere from 15 to 40 megs, and it bursts up and down. Amazon, same thing. So all these streaming technologies you're using are using burstable and bursty type of traffic. So for a household of 5, I think if you're at 150, you should be okay. But 150 should, do fairly well. If you're looking for something a little bit more on the conservative purchase side, but enough bandwidth for everybody to not clobber each other. Most of those people can be on something, a Zoom meeting or something like that. And remember that those technologies are designed around not using too much bandwidth so that they don't, they operate well, so to speak. That's what I recommend, 150 down. The up doesn't really matter. So whatever they give you with it. When you send an email, if you have an Outlook client or something local where the email actually has to leave, that's the only time you're really sending significant data up, or you're uploading something. Or if you're hosting a Minecraft server, your upload is the actual heavier part of that. But Minecraft doesn't use that much bandwidth, so it isn't going to really matter. Hope this helps you guys, all my family and my friends out there. Still available. Give me a call and help you out with this stuff and make sure that you understand it. But this is a good starter and a primer for you to understand what you're looking at. Take care. We'll see you all soon.